Testing. 1 2 1 2. Testing. 1 2 1 2. Testing. 1 2. Good evening, everyone. Thanks for being here. How's everyone doing? Decent? Okay. Okay, I got a thumbs up. That's nice. I'm Jackson. I am the organizer and I'm the host of AI for Developers and AI User Group. We are a community of professionals interested in learning about the latest AI technologies and tools, what they are, and how to apply them to our current workflow. And we host weekly meetups every single week here. We typically book 3 speakers and we have live demos and presentations on what the latest tools are. Also, want to say hello to the LinkedIn live audience as well. Thanks for being here. We appreciate your attendance. Okay, what else? We are having an annual conference down the street, 5 blocks from here, at 1 Jones Street at the Hibernia. This is in January. We're introducing tools on the main stage presentation track. We'll have over 20 speakers every single day, bringing together all 3 of our audiences. We have AI for marketers, AI for designers, and AI for developers. Over 3 days, we'll have a presentation track where you learn about new tools, and we'll have a workshop track where you can be trained on the tools. This is down the street, and this is happening January 31st, Developer Day. So there's the dates I just discussed. Marketer Day, Designer Day, Developer Day. If you want to grab a ticket, grab this QR code, and we would love to see you there. The venue is pretty interesting too. It's an old bank from 1892. It's actually the same bank that Patty Hearst robbed. It's actually a different branch, but that's okay. The point is, it's a beautiful building. It's 4 stories. The main stage presentation area has 2 full stories with a stained glass window, and in the basement, there's these great workshop areas where they used to store gold bullion bars, but it's great for a workshop. So I'm excited about it. Here's a picture of it one more time. Pretty neat. Okay, so that's that. And also, we have a social media challenge. I'd like to announce the winner from AI for Designers last week, and that's Ben Rowe. Ben, we will be in touch. He usually comes to the designer meetup, but I just wanted to announce it here. We have a similar challenge tonight. Ben is winning a free ticket to the conference, by the way. And here's the challenge. This goes for you guys too. Take a picture of the event tonight. Could be of me. It doesn't need to be such a flattering picture as Ben took of me, but it could be a picture of the presentation. It could be of our first presenter, Patrick, and mention AI User Group in the post, and do this by midnight Pacific tonight. So grab a picture, make a post, mention AI User Group, and by noon tomorrow, we'll figure out which post has the best engagement, and we'll announce the winner at the next meetup, and you will get a free ticket to the conference. Sounds pretty good, right? Okay. What else? Don't be shy if you'd like to present here. This is my actual email if you want to reach out to me. We'll chat. We like having AI tool creators, but also community members like yourself. If you're using a tool and you want to show how you're using it in your day-to-day, I'd love to chat with you. What else? Coming up are our next events, and these are not the events. My apologies. All the November events for the next series are booked on our meetup page. Take a look. We have AI for Developers on November 29th. So all those events are there. Take a look at the speakers. I have 3 speakers on each one. So see if you're interested in the content. For tonight, we'll hear from Patrick first, then we'll hear from Ajay, then we'll hear from Frank at 8 o'clock. We'll do a quick open mic pitch, which is right here. Come up here, queue up, and we'll have an opportunity to speak to the live audience here and the LinkedIn live stream to kick off networking. So we'll just do that. At 8:05, we'll network and meet each other and make that happen. What else? Doors close at 8:50. Okay, that's it. All right, without further delay, thanks for your patience. We're gonna hear from Patrick McFadin. He's the VP of Developer Relations at DataStax. The title of his talk is Failure to Plan is Planning to Fail, Unlocking the Petabyte Vector Store. And without further delay, here is Patrick.
Thank you. Thank you. Welcome to the Jackson Show. It's a wonderful day. And we brainstormed on this title, so I feel like it was a co created thing. It was very nice. And thank you for having me. My name is Patrick McFadin. Um, I'm not only doing developer advocacy work, I'm also an Apache Cassandra committer. Yep, that Apache Cassandra, the one you use every single day. And that's actually what this talk is about. so, I think this is the first thing I want to. I talked to maybe 4 or 5 people tonight already, and about 100% of you said this, right? Because this is the way it is, right? You're stressed out about not being like in tune. You're here because you want to learn something, right? And it's okay. This is a community of people that are in the same boat. Now, there might be a couple of us that are like ahead of the game. Don't raise your hand. That was not a raise your hand thing. But we are learning together, and of course, if you feel like you're falling behind, ask. And so, part of what I'm trying to say is we're all learning together. So let's try to make it easier on each other. Now, um, there are 3 things for success that I'm going to talk about tonight, just because I have 30 minutes less now because Jackson cut into my time, but not judging. But I like 3 things. 3 is a magic number. 3 is a magic number. So simple, private, secure, and performance for a low price. How about those 3 things to start with? Let's just do that for success. And I'm gonna demonstrate each one of these. And I said I was gonna do a high wire act and do some live stuff here. So let's do this. So let's start with simple. I don't know about you, but I've spent my life as a computer engineer doing complex stuff, and boy, the simple stuff sure is nice, right? And it seems like for my entire career, I've always tried to simplify things. Like, hey, well, let's build make files so we don't have to hand compile anything. Hey, let's use Java. That'll make it easier. No, it didn't. But then, hey, we'll use the cloud. Then you don't have to run your own computer. Oh, that sure is expensive. But then, hey, let's use AI and let us tell us everything, right? Well, we're gonna figure out if that worked out or not. But I'm gonna walk you through some real quick stuff here. So I work on Apache Cassandra, but I also work at DataStax. And part of what, if you've heard about Apache Cassandra, you know that, hey, this is a really interesting database, but I don't want to run that. And I agree. I'll run it for you. So let me show you like really quickly. This is our Astra page, but I think this is something I'm proud of that we're working on. We're making Cassandra easy for everybody. So I'm just going to create a real quick database here. This is my very own. Yeah, you can tell by the databases I have in here what I'm working on. And you're going to see one tonight that I have it running live right now. But, to create a database, I've reached my limit. What? Fine. This is why I don't do live demos. Dismiss. Hold on. I'm going to get rid of this one. No, I don't want to get rid of this one. Steve Jackson, I told you this is going to be a high wire act, man. Fine. I'm going to have to get rid of one of these, but I don't want to. All right, we're going to play make-believe for a second. To create a database is pretty simple. And damn it, I wish I could delete this one, but I guess I'm going to have to, right? So this is what happens when simple happens. How many of you have deleted a database and not wanted to do it? Yeah. By accident, right? And I'm like sitting here going, oh, yeah, this is going to be bad, but I'm just going to have to do it. Terminate database. And this is my favorite things. Enter the database name, DB engines. Okay, so that's fine. Oh, God. Oh, bye. It's gone now. All right. So I guess I didn't need any of that data. But you know what's great is it backed up. Oh, it's not gone yet. Hang on. So while it's terminating, one of the things that we've done is we've made it so all of these databases are very hands-off. You should only spend about 5 minutes of your life in this console, and that's to create a database. And what's happening behind the scenes is we're running Cassandra in Kubernetes. By the way, wrote a book about that. But it's meant to be totally hands-off. The scaling is really simple. You don't have to worry about it. It scales to 0. You only pay for what you use. And that's important because let's say Remember that cloud thing? Clouds can get expensive really quick. And what we don't want anyone to do, I've run Cassandra in production on a huge cloud. One of the things that happens often is that you wind up running a bunch of nodes that you don't need because you're trying to scale, right? You're all probably working at a startup and you think you're going to have the hottest thing since Instagram, right? Well, what happens at that point? You're going to need to scale. A lot of folks do these pre-scaling thing and then get way ahead of themselves. I'm going to come back to this in a second. But having scale, like being able to scale it up and scale to zero, means you don't pay for what you don't use. That's serverless, true serverless. So I'm going to switch. Hang on. While this is all terminating, told you this wasn't going to work, Jackson. So actually, let me back up. So I have created a database, and I'm going to create one at the end after all these delete. So I created a database earlier called Astra Demo, and I'm running this demo right now, as a matter of fact, on my laptop. Just to kind of prove it, here it is. This is a demo that I have running. That what it's doing is it's right now, currently, it's doing a double indexer on Wikipedia. So it's grabbing Wikipedia articles, creating an embedding, and dropping it into Astra as a vector database in an Astra vector database. So it's just doing this right now on the Wi-Fi. So that's why whenever I go over here and look at this, it shows that I've already stored 300 some megabytes, almost 400 megabytes of data, but and it's pretty active right now. I've had this running since this afternoon, and it's already had 341,000. Ooh, who's going to pay for that? Probably me. All right, but connecting to it, it should be pretty simple, right? And that's what we want to make it easy for you. Whenever you want to use a vector database. So, and what's great is Frank's going to talk to you about why you would want to use a vector database in two talks. There's Frank. He'll be over here in a minute. But he'll talk to you about some of the reasons you'd want to use one. I'm talking more about like the simplicity of using a vector database for your AI project. And connecting to it should be very easy and using the languages that you need. So for instance, Node.js, Python, Java, C++. Who's writing C++ code anymore? Oh, right on. Yeah, right, there's one. We got a driver for you. But I think what's more interesting is the API stuff. We have our JSON API, which is, I'm not saying it's MongoDB compatible because they keep changing it. So it's pretty close, but it's a JSON API. That means you can use TypeScript and that sort of thing. But most people are probably going to be using something like Python right now. And what we've done is we've built some really great libraries for you. We have one that's called Casio, and we work pretty extensively with Langsmith or the LangChain project and Llama Index, so that in the whole thing of simplicity, if you are writing a Python generative AI application, you don't have to do data modeling. You just put in the token, and it will do all the data modeling for you. And what it does is it lets you do things like use LangChain for creating agents and that sort of thing. Llama Index, same thing, without actually having to think about the database. Because whenever you say you're chatting with your PDF or something like that, that should be like 3 or 4 lines of Python. And it makes it really easy to do. And that's what Casio does. And now what we're working pretty extensively on is LangChain.js and Llama Index TS, TypeScript, for the front-end applications. And if you are building front-end application, generative AI applications, that's probably what you're going to be using as JavaScript or TypeScript, because that's what you do. You use React or Vercel, Next.js, something like that. So the other thing that's really critical is this privacy and security. And it's funny because I always thought that was more of an enterprise topic, right? But generative AI has freaked everybody out, right? Because there's just so much it can do and get into your business, right? And let's say you're doing something with generative AI around healthcare or financial data, which is pretty. I know a lot of startups that are doing that. It seems to be very popular, healthcare especially. That's not data you want to mess around with, because there are laws on that, and It's hard to be a startup. Like Instagram, I mentioned Instagram was easy. Take a picture, store it, share it with your friends. Great. Where's the security in that? It's literally sharing, right? And that's an easy, that was a great startup idea. But now with generative AI, the real magic is like what it can do for personal stuff for an individual. Um, I have an example. Like I would like to say, hey, could you review all my bank transactions and tell me some interesting things? One of We have a bank that uses our vector database, and that's actually one of the things that they do is you can go into the banking app. This could be a good startup idea, by the way. You can go in the banking app and say, yeah, tell me how much I spent on fast food last month. Now, that's a pretty general thing to say, right? But it requires they access your personal banking information, and the LLM will take that natural language. All right, fast food last month. Okay, parse that out, and then go do a vector search on all of the financial data, your personal financial data. But it also returns back and says, "Oh, you ate too much McDonald's last month, right?" Which I'm not saying that's me. Could be In and Out probably, but that is an example of a really cool app that has zero chance of being insecure. I do not want someone to ask, like, oh, how much did you spend on PlayStation? Because that's an embarrassing answer. So I don't want anyone to know that. But it's also like healthcare information is really tough. So this is something that we've really pushed hard in our world. Um, we, when you spin up a vector database, we have this trust website, which is, these are like, it's so funny because I think of like we've gone through this process of going through the ISO 27001, 27001. Like, who cares about that? A CISO. You know who you got to impress eventually is your CISO. But it's also like HIPAA requirements, PCI, SOC 2. All of those are what keep you from getting in trouble when you're working with other people's financial data or healthcare data. And it's become super relevant with generative AI applications. And we provide that. When you create a database, this is what comes with it. And if you need to have a HIPAA compliant application for your startup, there's just a few forms you sign and poof, your data is now HIPAA compliant. You can get government grants and all kinds of stuff because you're already there. That's hard. It took us years to get all these things, and that's something that we do and we're pretty proud of. All right, let's see where my databases are. Oh, all right. So now I'm gonna go back to the beginning. I'm gonna create a database. Let's see how simple this is. Thank God. I'm just gonna call it Jackson because this is his show. So I'm gonna create a new vector database. Oops. That's a bad interface problem. And when I go to create the database, I'm going to say, come on. Did I click the button? Ooh, I think I killed it. This is a bad demo day. This is why you don't do live demos. I think it's because it was Jackson. Yeah, I can't click on the button. I don't think that's going to be it. No, it's because I can't click. There's something going on with my browser that I can't click on anything. Wouldn't you know? Hang on. I'm going to blame it on your screen capture. I haven't finished my update yet. I mean, I'm sure that's what it was, right? God. Yeah. I'm not going to update it in my browser right here. There we go. Now, so now it was my screen capture. So I turned off the screen. Okay, never mind. So back to this, you can create like which region do you want to be in? And I'm going to use Google Cloud in this case. And boy, as simple as I thought it was going to be, but it takes a couple of minutes to start. Jackson, you have your own database. And it's right now it's spinning up my instance behind the scenes. But now what I can do is I can start getting into like things like how do I want to connect to it? I can generate tokens for this. I want to be a database administrator, but we have a lot of we have these really specific roles that you can create again for security and privacy. Back to that. Like I only want a read write service account and that's it, or I only want an API read and write user only. I don't want it to be able to manipulate anything. Well, generating the token. I mean, if we haven't seen one of these 1,000 times, right? Tokens are how we get the job done now. But that's what I use to connect to the database now. Really simple. And I can download those details if I want. I'm not going to. But in this case, I have a demo, this demo that I'm running here. This is a great demo. It's JavaScript, Java, and Python all in one app. So this is the demo that I was running over here is it's using Java Spring to load into the database. So you can see the server is all built in Gradle using Java and Spring. The embeddings are done by Python. And then the front end is all running with Node and React. So this is a full stack app with the only thing I'm missing is C++. Maybe you'd like to add that. PRs are accepted. Yeah. But I just give it the token for this particular app. This README shows like, I'll give the detail. I have the link for this that I'll give Jackson and he could share it with you. But in the end, what you get is this thing it will be doing a lot of embeddings in a concurrent fashion. So let's go back to this. All right. So private and secure is one thing, but it's also this performance for a low price. And this is kind of wrapping things up, but you should not have to overpay for a database and you should get the most performance for it. And that's generally not a cloud thing, right? Usually using cloud is not cheap unless you're using an S3 bucket or Glacier or something like that, right? Which is really cheap, but that's not very useful when you're writing an application. And I'm just going to click through this to avoid the issues with my screen. But since we're built on Apache Cassandra, this is a high scale database. This is a slide that Apple did. They have hundreds of petabytes of data running in Cassandra, and it runs across multiple regions around the world. And Apple does not do downtime. And what we want to do, go big. There we go. How's that? Better? Better. There you go. Now you can see it. But the other thing is that we've built our database around the idea of concurrency. And that demo that I'm running right now is what's showing that. Concurrency is that you should be able to do reads and writes at the same time without it affecting the speed of your database. And so I like to pick on Pinecone. You're welcome, Frank. But Pinecone can't handle this. If you start doing writes to a Pinecone database, and your reads will start dropping like a rock. And why? Because it can't do concurrency. That's a hard problem to solve. And that is the performance that people run into all the time. And that's a big database problem. We solved this with Cassandra about 8 years ago, and it took us a few years to solve because it's a hard problem. So concurrency, the thing that we're doing right now, is really key when you're building an application and not just doing batch loading of vectors. You're actually writing an application. Users will be reading and writing at all times. And probably that's going to be, if you haven't heard this yet, you're probably going to be writing agents. It's not going to be a chatbot. Yeah, chatbots are cool for today. You should be doing chatbots right now. Next year, you're going to be writing agents. And those agents are going to be really creating a lot of load. And this is a great link. Yeah, I put the QR code for, this is Andre. Andre gave this great talk about agents at a meetup, kind of like this. The link has his full thing, but it's really cool because you think like, oh yeah, I get it. That would be cool. But the other thing is that's going to create an incredible amount of load on the system. All right. So you can do this today. You can use that link. That's my link if you want to log in. It's really simple. I got to wrap things up because I'm almost over. I'm going to keep you on time, Jackson. But you can use that link. We have a great startup program. So if you use your business email address, we will, and we have an intercom inside. Just let us know who you are. Once you get involved in this startup accelerator package, then we have lots of free credits, lots of free help. We want to help you get there faster, and we work with startups all the time. And it's the most exciting place right now in Gen AI is the startups, right? I think there's so many cool ideas and really interesting things happening in the startup space right here in San Francisco. This is why I spend a lot of time here. We should work together. I think it would be nice to go faster. And then one shameless plug, I'm the conference chair for a conference coming up in December. It's the AI Developer Conference and the Cassandra Summit. We're having two conferences in one. I have discount codes if you want to connect with me on LinkedIn. I would love to hear from you. But it is this is two conferences, and they're both being run by the Linux Foundation. So this is an independent event, but like I said, I'm the program chair for that. Right now, we're working on keynotes. Got some really cool confirmed keynotes from folks like Jerry Liu from the Llama Index is going to be there. I know for sure. Folks like that, and it's just going to be a lot of great content. We're expecting a lot of people, but it's at the San Jose Convention Center. Plenty of room for everybody. So I hope to see you there in December. Connect with me on LinkedIn. And I got 5 minutes for questions. So questions.
All right. Let's do some Q&A. Any questions for Patrick? Can I just ask if you could stand, just so the virtual audience can see you as well?
Yeah, my question was like, why do you have like a lot of servers, like Python and stuff, like front end for Python and so on? And what's the reason for that? If you can share, thank you.
Oh, why does that demo have all of those?
Yes.
Just so we could show all the different code. It's because I don't know if you know this or not, but people get really particular about what language you use. So we just used them all.
Yeah. Is there any particular, it makes it faster, or it makes it like something like that,
None
you
at all.
choose like certain kind of like server for each of them, like the function?
None at all. As a matter of fact, I don't recommend you do this in production.
Okay, thanks.
It's usually best to stick with one language or another. I mean, using Spring, for instance, with JavaScript and React is a pretty good combination. But mixing Python in there, I'm not sure why. But again, for demonstration purposes, it makes sense because then you can see all the different ways to do this. Yeah, this is not probably a typical. I don't know if anyone's running this in production. Tell me later. What's next? Yeah.
So, as far as the transition from where we are from chatbots to AI agents, what has to happen, like technologically? Sorry. What has to? Sorry. What about what about the GPT-4 technology has to be improved for us to go from chatbots, like good chatbots, to like powerful AI agents?
Yeah, that's interesting because I was just at the AI engineering summit, and that was a discussion. Agents were a big discussion. But what's it gonna take? There's two things that I think are really critical. First of all, is having good agent frameworks so that that they are able to do the job that they need to do without failing. Agents should be able to run autonomously and without much intervention or interaction with humans. But GPT-4 is good. Llama, we have Llama 2. I mean, there's a lot of great LLMs out there, but they're not exactly sentient life. That's not AGI. How much? I think that's the question. How many agents are needed to get AGI? Now, hang on to your hats, everybody, because GPT-5 and Gemini are probably going to be released this year, early next year. And that's what everybody's a little freaked out about. I mean, everybody not in this room. Everyone looks calm here. But the world in general should be a little freaked out about this, right? Because GPT-5 is going to be a remarkable upgrade from GPT-4. And just the amount of research, look in the last year of where LLMs have gone, just in open source. LLMs are teaching LLMs. If you look at Orca, for instance, Orca is a very small LLM that can almost match GPT 3.5. And so what's going to happen in 3 years, 5 years? That's amazing amount of time. But yeah, Gemini and GPT-5, along with the agent frameworks, is going to be, I don't want to say scary. I hope that it's actually really cool and useful. I hate to say the word Siri. Everyone's phone just freaked out. But I don't want Siri anymore. Siri's lame. It's like, it's so boring. And it's great for timers. But I want to be able to tell Siri that thing like, hey, how much did I spend on fast food last month? I want to be able to converse. I want Jarvis. Everybody wants Jarvis, right? Thanks, Iron Man. You broke us all. But I think that's where we're going. And I think it's going to happen pretty soon. Good question, though.
The quickest question ever asked and the fastest answer.
Cool. Yeah, thank you for the talk. Quick question. You mentioned working with startups. What are some lessons that you've seen, things that worked well and didn't work well for startups?
You mean like startup ideas?
No. I mean applying some of the technology that you're working on and just in general, not on ideas, but operation, execution, engineering.
I mean, first thing it comes down to is you have to have a clear idea of what you're trying to accomplish with a clear path to how you're going to make that work. The technology is just the implementation. But what I could say is if you don't have a good balance between implementation and execution and good ideas, then you will never get anywhere. I hate the whole idea, I'm an idea guy, whatever. I could throw a rock and hit 10 people with ideas in San Francisco. And execution is great, but if you're not marrying it with the goal, I'm sorry, startups are supposed to make money, and I work for an open source project. I'm not supposed to make money, but startups make money. And so if you don't have an execution path that turns your idea into revenue through the implementation, then you're doomed. So good balance between those two things. All right.
Thank you. Thank you so much, Patrick. Let's give him a round of applause one last time.
Yes, good.
Okay. Up next, we have Ajay Juneja. He's the founder and CEO of Speak With Me. Ajay has been working with Llama 2 for the last, I think he'll tell you better than me, but couple months. And he's going to share his insights on that process with us. I think it's going to be really interesting. And we just got to get this high-powered laptop powered on. And I think we just about have that done here. And Ajay will tell you more about that. But yeah, I'm really looking forward to this. And let's just make sure we are entirely good to go here. Okay. And without further delay, here is Ajay getting started.
And let's do.
Just working with HDMI.
Oh, wait. Now I remember it's over here. Present.
Okay, let's see here.
Okay. Hello? Can you guys see stuff? Oh. Wait. I think I know what they need to do there.
HDMI signal. Interesting. So I think one should try direct HDMI. This worked when we did.
What's there?
Okay, let's hold here.
No. Worked earlier. Okay, let's. I mean, we can try direct.
Yeah, let's try direct HDMI. It's on the other side.
Yeah.
the most complicated part.
Yep, it worked 2 hours ago.
My switch. I didn't know. Oh, nothing. This is just the whole amplification.
Now, I mean, I can reboot if you want. Input not found.
And HDMI connection works. It's just something with AJ's.
Oh, that's interesting. I think Linux has an issue.
It worked when we did.
Yeah, but that just crashed. So,
We're doing like a screen recording thing. Why is it's the HDMI input? I think.
I think something crashed.
Do you want to? Should we have Franco next?
No. I'll just reboot. It'll work. Let me just quickly reboot.
RJ, can you give me some? Okay. We're just doing a reboot on the computer here. Llama 2 is going to be run locally, if I'm not mistaken. 4-bit and 16-bit. This is a live demo of Llama 2. So, and we did an AV onboarding 60 minutes ago, and it worked. He's also running a Linux Ubuntu machine, so this is fun. So we're just doing a reboot, and we're going to get this going.
Okay, let's see here.
All right.
That.
So yeah, HDMI is a lot of fun, and here we are, live demo of Llama 2. Here we go, AJ, you're on.
Yeah. Okay, so let's do. Okay, hi, I'm Ajay. I started Speak With Me back in 2005. So to give you a background, we built the voice assistants for TomTom, Waze. We helped them with their CarPlay and Android Auto integration, and Volkswagen Group. And we were first to market in 12 different things over almost 20 years. To give you, so we started with discrete hidden Markov models, moved into continuous hidden Markov models around 2009, and then did deep learning on FPGAs, then deep learning on NVIDIA graphics chips. We were among the first to support the NVIDIA Tegra K1, K2, X1 and X2, and Xavier chips that are fairly common today in robots and cars. And yeah, so I'm coming from a world of building language models. Also from 2015 to 2019, we focused on a generative AI to build the language models for us. Basically, I automated one of my 5 jobs. And that saved us about 90% of our time. And there's some things we did before large language models were a thing. And so we are tinkering now with some large language models to see some ideas for some of our tools, if how useful they might be for large language models. What's the difference between a language model and a large language model? Size, obviously, and then the use of transformers instead of just RNNs. So transformers add a deeper level of contextual memory, and I think that that's been useful, and some level of inference via vector databasing and understanding large chains of vocabulary and how they interrelate with each other kind of automatically. And before that, we had to, I'd say before transformers, we had to kind of give that information to the data manually. And so that's a huge reduction in work for people. And Yeah, so I started tinkering with Llama 2 in August. I have to say that I'm grateful that it's open sourced because it helped me personally realize that what they were doing was not very different from what Speak With Me was doing before that. Because I could, look at our code and their code and be like, oh, that's not that different. And I'm pretty certain some of the compression techniques we had where we turned some 3 billion parameter models into sets of about 68,000 to run on hardware a few years ago, that some of those would be quite valuable for the world of large language models. So this is not my product I'm demoing. This is Facebook's Llama 2. And before I get started, how many people have heard of Llama 2 before coming here? Okay, how many people have installed Llama 2? 5 of you, okay. How many people have chatted with Llama 2 or conversed with it? Okay, a few of you. All right, well, so first thing I have to say, you need a pretty high-powered machine. This is a 2-year-old Razor. It's got 8 cores, 16 threads, 32 gigs of RAM, and an RTX 3080 with 16 gigs of video RAM. And this is running on Ubuntu Linux. And so first, to quickly install it, you'll need Python 3.8 and Git. You've got to make a Llama 2 directory on your machine. Go download those 2 repositories. If you are downloading all the models, which I'll talk about on the next slide, you're going to need about 217 gigabytes of space. So, and we'll say that this machine can run the 7 billion parameter model, but it cannot run the 70 billion parameter model unless you've got some cool compression tricks beyond, maybe if you implement some of Speak With Me's compression tricks, you might be able to. But in absence of, since we haven't debuted anything like that yet, so yeah, so just as a warning, for the 70 billion parameter models, you're going to need a bigger machine, probably something in a data center, like an H100. So there's 2 repositories. One is the Facebook Llama repository, and another is some C++ code so you can connect with Llama 2 as a chatbot. And you've got to build that too. And then you have to request access to the Llama 2 models. And you're going to get an email. It looks like this with this very long download link in it. And this download link is only valid for 24 hours. So if you requested access and ignored this for a few days, guess what? Your link won't work. So you got to request access and be on the ball and go download it while you still have access. I made that mistake, so you know. So. Yeah. Then you basically have to download those models. We're not going to do that part live because that will take a while. And then run these following commands to essentially get everything ready to go in your Python virtual environment. And then these models are typically 16-bit floating point. For reference, Speak With Me actually uses 32-bit floating point models for speech recognition. And for text models, you can get away with less precision. So if you want these things to run quickly, although you will see some degradation and different behavior, you can quantize it down to 4 bits, which I have both the 16-bit model and the 4-bit model here. If you want to get familiar with quantization, just go back to the Sony compact disc and the Philips standard and see what happens when you fiddle with your audio files and convert them to 14 bits or 8 bits and see how they sound. You can use a product called Audacity to do that, or other Adobe Audition also is great for that. All right, so now we're gonna start running some things. I also have an activity monitor, which I may pull up sometimes while I'm running some of these things so that people can get an idea of just how much of this machine is getting hogged. So first I'm going to make the text bigger here. So let's... Can you guys read that? Yeah, okay. This is where it is. Okay. So first we're going to run the 4-bit version. So just to kind of make sure you guys can see all this, you can get some idea of what's going on with the attentions and the weights and how many parameters are getting loaded. And this, the cool part is with the source code, you can get a lot of ideas of the structure. And you can see it's using up about 4 gigs of RAM. And we're going to start talking to it or typing to it. All right, so let's see. Cookie Monster. Let's see. Cookie Monster is having a fight with Miss Piggy. I am a rubber chicken. How do I mediate? Okay, so I wrote, Cookie Monster is having a fight with Miss Piggy. I'm a rubber chicken. How do I mediate? I see. Well, mediating a fight between Cookie Monster and Miss Piggy can be a bit of a challenge, but I'm sure you'll do a great job as a rubber chicken. Can I help you with anything else? Okay. I need some chocolate chip cookies. To calm Cookie Monster. To calm Cookie Monster down. Can you give me a recipe? Okay, so I'm making it generate a recipe here. And it's doing a decent job so far. Also remember, this is the 4-bit model. We're gonna switch to the 16-bit model and you'll see how much slower it is. And while I'm having it doing the generation, you can see how much it's taxing the machine. It's getting kind of hot. It's it's got a Core i9-11900H with 32 gigs of RAM. So it's 8 cores, 16 threads, a couple generations ago, state of the art. Also, note how after a while, it gets kind of to the end of its context window, and it takes a while to keep going. It's very interesting as you let it keep going. Sometimes you'll see extraneous training data come in. See? So this is an interesting behavior in large language models. Like, how are chocolate chip cookies related to, I guess, making coffee? Okay, that's interesting. But how does a code block end up in a recipe for chocolate chip cookies? I did ask it to make something, right? So that's interesting because make also goes with GNU make and compiling code, right? So I'm apparently going to let it keep going, and it's giving me a code block to make coffee. Okay. So, did anyone talk about large language model hallucinations? I mean, I'm not sure that the coffee will calm Cookie Monster down, and I really don't think he understands the source code. So, and you can just prompt that by, letting it run a little further. So it's very interesting because I actually don't know where this ends. And another thing that I've found in Llama 2, which we didn't experience in the world of speech recognition, is it's very inconsistent. It doesn't give me the same answers to the same prompt. It gives different answers to the same prompts. And I say that we don't like that behavior in speech recognition. We want the output to match the words you spoke, right? And we want it to do that consistently for the same audio file or the same human speaking the same words with the same ambient noise conditions. So this is something, I don't know if anyone else has experienced this, but it's interesting that it keeps going. Doesn't really stop. Oh, it finally did. Yeah, so, all right. So, what is a meaningful life according to Douglas Adams? All right, how many people have read The Hitchhiker's Guide to the Galaxy? Cool. So this one gives different output each time, too. Well, I asked for not the meaning of life. What is a meaningful life? See, this is, I'm having fun as a linguist here. And it's very interesting because the 16-bit version gives a very different answer than the 4-bit version. I actually like the 4-bit answer better. So a meaningful life is filled with wonder, curiosity, and exploration. I like that. It is a life that is not wasted on mundane tasks, but rather one that is filled with adventure, exploration, and a constant search for the absurd and the ridiculous. I like that. All right, now, what's interesting is that as you let it keep going, it'll actually, last time I did this, it referenced the Wikipedia author. So now, I guess today, in this moment, it's going back to code for making coffee. I can't wait to ask it, what the hell does making coffee have to do with the meaning of life? That'll be our next question once it gets there. Okay. That's good. That's cool. This is a useless agent now. So I actually wonder, what is Z31417 in relation to Douglas Adams in the data? Patrick, who did the vector database things, can you explain how these vectors coincide? Would you like to know? I want to know how making coffee has anything to do with a meaningful life, other than waking you up. Wow. Okay. I'm killing it now. If it decides to kill.
AJ, would you like to do a little Q&A, take a few questions from the audience?
Sure, especially since it's I tried my best to kill it, and
It's dead.
it's
Let's
there
see.
we go.
So actually, I have a question from the LinkedIn virtual audience. This is from Druv Patel. Hey, Druv. What's the parameter size of Llama 2?
I had that on the screen, and now I forget. I'd have to rerun it. I mean, this was the 7 billion parameter model that I was running. So I hope that's the answer to your question. 7 billion parameters.
Let's do some audience questions. And just a reminder, if you could stand, and when you're done asking a question, if you could either pass the mic back to me or to the next person, we'll keep the continuity going.
An almost obvious level question you were talking about, inconsistency of answers. What about running that at temperature 0? Are you still getting very inconsistent answers at temperature 0?
Is temperature 0 as in 0 degrees centigrade? Or what is temperature 0?
No, so there's a model parameter with almost all of these models that sets the level of creativity of the response. And for something that you want to be more deterministic, you want 0. More creative, it's going to be like above 0.7. So I was just curious if you had played around with that. It sounds like no.
I have not played around with that, but I have noticed the 16-bit model doesn't hallucinate as much and is far more boring and less creative.
Okay, thank you.
In fact, I'm running the 16-bit one now, and we're going to ask it the same question about the meaningful life.
Let's take the next question while AJ runs the 16-bit model.
How do you get it to not go on like insane rants that are unrelated to the prompt?
I mean, speaking in general, you probably want to have a threshold where you have some cutoff, and probability cutoffs would be my guess. And I have to dig into the actual parameters. But there's one in the command line that there's a repeat penalty, and have that set at 1. You might want to change that. And then you also can change the context window. So some combination of like a penalty and the right context window for the right questions. That's the problem, is you can't really control what your users are going to ask. So figuring that out for your product is going to take some fiddling, right? And notice what a different answer it's giving in 16-bit mode, and also how much slower it is. Like, this is like using a computer from the 60s. Right? So we asked the 16-bit model, what is the meaningful life according to Douglas Adams? Same exact question as the 4-bit model. Douglas Adams, the renowned British author and humorist, once said, the meaning of life, the universe, and everything is 42. So see, I mean, it's very interesting that if you want a creative model, I guess you got to make it stupid. All right.
Let's take another question from the audience, if we have time. Anyone else from the audience? No one? AJ, any other differences you've noticed between 4 and 16?
I mean, the 16-bit has a lot more memory used as well. I mean, that's pretty normal. Like you can see here, 12.8 gigabytes used. It actually, at some level, uses up less CPU power because it ends up finding the end a lot faster. Whereas I think with the 4 bits, it can't figure out where the hell the end is. And so maybe that's something to think about when, if your model precisions, if you're thresholding too much, it doesn't know where to stop talking.
Okay.
Or stop talking and listen would be, I guess.
AJ, I got a question. How do you push your machine, what interactions with Llama 2 can push your machine the hardest in terms of CPU usage or other?
I think the parameter size of the model, mostly. I mean, you'll run out of memory trying to load the 70 billion parameter model. And I think the 4-bit model does, so quantizing the 4 bits means essentially the probability chain just keeps going a lot longer. And so you end up using more CPU power for that stuff, basically.
Okay, last question real quick.
Yes, you started the conversation here with ChatGPT 5, and there were concerns amongst humanity about the release of it. What's the difference between what you're showing us now with Llama 2 and what we may or may not be frightened about what's coming, right? This is 16-bit. What is ChatGPT 5? Is it 32-bit, 64-bit, 128-bit? What's the difference between the two?
I mean, if I am building large language models in terms of evolution, I would really want to study them for a while first, for hallucinations and creativity and finding balances, and really publish that data and the results, because these are for us as a community. And when people don't know what each parameter does and what the output is, and when you're talking about in AI, can I trust the output? It's a big problem right now for generative AI, is how do you trust the output? But at the same time, you kind of do enjoy it being creative, because it can come up with poetry. It can come up with some absurd things that are hilarious too. And I mean, frankly, I would like a humorous AI. So I think that some people will have some fun with this. I mean, look at what it just said here. As a rubber chicken, you could provide comedic relief during the baby shower, or perhaps offer to be the LeMay's couch for Cookie Monster and Kermit. Just remember to be respectful and kind to the expecting parent. And also, this model's too damn polite. Like, I really do think we need some uncensored models out there. And I mean, someone, here's a business idea. Seriously, a generative AI TikTok profile that's like telling jokes. You really could go, like, you pair this, you output it to a great text-to-speech voice that's hilarious. You add some rhythm and music to it and some comedy beats, and you got a business there, and you got an audience, right? And you could probably make a fake TikTok. I mean, you could make a TikTok profile out of it that gets millions of users. And
okay, let's give Ajay a round of applause. This was great. Really enjoyed it. Thanks so much. Awesome. Okay, that was great. Next up, we have Frank Liu. Frank is the head of AI and ML at Zilliz. He is going to tell us about practical RAG, choosing the right embedding model, chunking strategy, and more. And without as much delay as last time, we'll have Frank Liu.
All right, we good? Perfect. So thank you for the introduction, Jackson, and welcome everybody to my talk. I'm gonna be talking about what I like to call practical RAG. And it was a great introduction, I think, that Patrick did earlier, to vector databases, and also a great introduction to large language models here, Llama 2 in particular. And I think RAG is going to be a great tie-in to both of these earlier talks. So I just want to introduce myself real quick. Hey everybody, I'm Frank, Director of Operations, Head of AI and ML at Zilliz. And I do everything from talking to our users, training embedding models, to sometimes I run the dishwasher at night. So a little bit of everything here and there. You guys are the first group that's actually laughed at that joke, so I appreciate it. I will try to bring this slide up at the very end. So if you guys want to get in touch with me, if you have any other questions, feel free to follow me on Twitter, ask me anything on LinkedIn, or shoot me an email as well, right? Happy to do so. Happy to answer any follow-up questions that you guys might have at the very end. So a quick sort of table of contents, so to speak, into what this talk is going to be about. If I have time at the very end, I'll try to get into some of the code as well. But if not, I'll sort of leave that up for everybody to take a look. Who is Zilliz? Who are we? I'll talk a little bit about what we do, especially when it comes to vector databases, when it comes to retrieval augmented generation, so on and so forth. Give a quick recap into vector databases. Patrick gave us a great initial talk. Thank you for that. And then we'll dive really into the meat of this talk, right, which is building a RAG application, and in particular looking at the RAG stack and what are some of the interesting things that we can do with LLMs plus vector databases. And then I want to leave everybody with sort of a sneak peek into the future of vector DBs as well, right? Where are we going? Where is vector databases going to be in 2-3 years? In addition to LLMs, what are some of the other awesome applications that are out there? And what are we going to do with it in the future, right? So without further ado, who are we? We are a company. We were founded in 2017, and we are the key maintainer for Milvus. Milvus is the world's most widely adopted vector database. But in addition to Milvus, we are a maintainer for a number of other open source projects as well. It's very much a part of our DNA as a company. We're close to 120 people right now and growing. So if any of you guys are interested in joining a vector database company, feel free to come up and talk to me afterwards. Happy to take some resumes. And I want to dive into the next session talking about vector databases and recapping what they are, what they're good for. The key thing to understand is that vector databases are for unstructured data. Whereas you have relational databases that are good for tabular data, you have NoSQL databases that are good for objects or JSON documents. Vector databases are for unstructured data, and unstructured data is anything that doesn't have a predefined data model. Great examples of this are images, video, audio, text, but a lot of less mundane examples include DNA, protein structures, IoT data, so on and so forth, right? So any of these types of data is considered unstructured data. And by 2025, there's going to be about 175 zettabytes of data globally. I think a zettabyte is 10 to the 21 bytes. About 80% of it is going to be unstructured. I mean, that is a shit ton of unstructured data, pardon my French. And that is why vector databases are so important. That's why we need a way to be able to store, index, and search such a large quantity of this unstructured data. And the way that we do it is with vectors, hence the name vector database. You take your unstructured data and you use an embedding model, or you use some sort of handcrafted model to turn them into embeddings, and you store those embeddings inside of a vector database, and then you can perform what is called approximate nearest neighbor search. And the key property of embeddings that vector databases use is the idea that vectors, which are close to each other, are more representative of similar data at your input. So if I have two images of, let's say, German Shepherds, running through a field, and I run them through a well-trained image embedding model, the embeddings at the very end of that model are going to be very, very close to each other, right? And the analogy that I like to use is, while we speak, while I'm giving this presentation in English, vectors are the languages that machines speak. Specifically, they speak the embedding models, and vectors are the words. And some of the amazing things that you can do with vectors, I've sort of shown here. This is actually from the ImageBind paper from Meta, I want to say probably about 2 or 3 months ago. You can do cross-modal retrieval. So if you have a vector that corresponds to audio of a crackle of a fire, that actually corresponds to, in this very, very high dimensional nearest neighbor space, images and videos of fires. And one of the other things that you can do is also embedding space arithmetic as well. If I have a swan, or I'm not sure if this is a swan or a pelican, and I add an audio snippet that corresponds to waves, the output that I get when I do my nearest neighbor search inside of a vector database ends up being that same bird, that same animal, except with an ocean or with waves in the background. This is the power of vectors, and it is this power that vector databases leverage to help you gain insight into all unstructured data that you have. I'm not going to talk too much about this. This is really diving into Milvus, which is the vector database that we have built here at Zilliz. And I really only just want to draw your attention to two things primarily. The first is that we have clear separation of storage and compute of your worker nodes and your object storage. And at the same time, we have separation of different types of compute as well. So you have query nodes for querying, you have data nodes for ingestion, and you have index nodes for indexing your data. And I won't dive too deep into this architecture, but if you guys have any questions about it, feel free to come up to me after this talk. I'm happy to answer anything that you guys might have. So I'm going to jump right into the meat of the talk here, which is building. I want to talk a little bit about the RAG stack, right? And for those of you who are a little bit newer to retrieval augmented generation or a little bit newer to generative AI and don't quite know what RAG is, no worries. I will go into that right now. And what retrieval augmented generation is good for is giving your large language model, such as Llama 2, context into your internal documents or your internal data. How does that work together with a vector database, right? You can imagine I have a prompt. I'm trying to prompt my large language model, let's say a question or anything of the sort. And what's going to happen first is it's going to hit a vector store or a vector database, and that vector database is going to retrieve the most relevant documents that are related to that prompt. Once I have those most relevant documents, I then send those along with the original prompt back to the large language model. And that's what gives my LLM the capability to do reasoning, to do question answering, summarization, so on and so forth over my input data. Now, this diagram in particular, I apologize, it's a little bit fuzzy for folks in the back. It is actually from the LangChain blog. I'll figure out a way to share these slides at the very end, so that if you guys want to, click into this link, click into the URL, read a little bit more about it, feel free to do so. You guys are capable of doing so. And for this architecture diagram, I want to draw your attention to three key components. The first is similarity search, which we talked about a little bit earlier in the earlier slide, using vectors, using embeddings, and storing them inside of a vector database, right? The second is the vector store or the vector database itself, and the third is the large language model. Now, these are your three key components to a retrieval augmented generation or a RAG stack, and these are what we are going to talk about a little bit more in depth in the upcoming slides. The first thing that I want to talk about is choosing an embedding model, right? Now, I'm going to get a little bit more advanced here for some of the folks that are a little bit more into RAG. When we talk about an embedding model, when I talk to a lot of folks out there, both in and around AI ML, as well as just developers, solo developers or early stage startups, a lot of people are just using OpenAI's embedding endpoint. I don't know, it's probably very hard to see down there, but it's actually ranked number 15 on the MTEB leaderboard on Hugging Face. It is actually not the top performing model on the MTEB leaderboard. And most of your SOTA embedding models are actually involve some sort of pre-training, either with unlabeled or weakly labeled data, in addition to supervised fine-tuning. Now, if you find any type of model that does that, you should be able to get pretty good results out of your embedding model. My personal recommendation for good embedding models are actually the GTE series of embedding models and the E5 series. Both of these actually you do pre-training in addition to supervised fine-tuning. GTE in particular uses the Common Crawl dataset, Archive, Wikipedia, so on and so forth, and E5 uses a proprietary dataset called CC pairs. I think if we go back to this slide right here, you'll see that both GTE and E5 rank pretty high. So GTE is actually ranked 3, and E5 is actually ranked 6. So multimodal E5 is actually ranked 6, right? These are my personal recommendations. These are models that I've tried and I've used that seem to work pretty well, right? For both enterprise and for just solo developer experience. Both of these are also open source, so you don't have to pay for an API endpoint. When it comes to the vector store itself, right, you're going to want to choose a proper or an appropriate index. And there's multiple different types of indexes out there. There is, locality-sensitive hashing, hash-based indexes. There's tree-based indexes, IVF indexes, and graph-based indexes. This actually deserves maybe an entire series of seminars on its own, an intro to all these different types of vector indexes that you can use in a vector database. So I won't dive too deep into any of these. I'm just going to give you guys a cheat sheet here. In Milvus, in Milvus or Zilliz, excuse me, all of these are actually available for you to use as an index. If you want 100% recall, 100% accuracy, you're just going to use a brute force index, right? All of these other indexes, they do approximate nearest neighbor search. If you have an index size that's between 10 megabytes and 2 gigabytes, I recommend an inverted file index. Anything higher than that, I recommend HNSW, which is a graph-based index. If you're getting to the higher ends of those, you should add some sort of quantization, right? Either 16-bit, BF16, 8-bit quantization, 4-bit quantization. We've also tried 2-bit quantization as well. It does seem to work pretty well. And if you have a very, very large index, if you have lots of vectors that you want to store, you should use a disk-based solution such as disk ANN. When it comes to LLMs, give me 1 second. I'm going to see how I'm doing on time here. Okay, so I have about 5 minutes left. When it comes to LLMs, there's a lot of different options to choose from. And these are just two of the leaderboards, as well as, I don't know if you guys can see in the lower left-hand side, that's actually a survey of large language models. And you can see the number of papers for every month just continually to climb up. And there's a lot of surveys out there. There's a lot of large language models and a lot of ways that we can evaluate them. And to distill it into a single slide is very, very hard. Overall, GPT-4 is still the best performing LLM. And you'll also want to ask some key questions for your application. What are you trying to build, right? What are you going to need from the LLM in particular? Is it Q&A? Is it summarization? Is it reasoning? Is it something even more advanced than reasoning? And once you understand that, then you can go to these leaderboards, you can go to these survey papers, and you can understand, okay, this is what I need from my LLM. This is probably what the best performing LLM is. And as always, if you do use some open source LLM, always use the latest optimizations. Use quantization, use flash detention if you're training, and many of the other optimizations out there as well, right? And then the last but not least, I want to talk about choosing a chunking strategy. And due to context windows, again, talked about that in the previous Llama 2 exercise there. Due to context windows, chunking is a necessary evil. And you should always, always, always use some sort of context-aware chunking. Don't chunk just based on the number of tokens. There are some great libraries that can help you do this. So both Spacey and NLTK are libraries out there that can do the chunking, the context-aware chunking for you. It'll end at a sentence or at the end of a paragraph, and it gives you much, much better results than if you just do, let's say, fixed length chunking. And the other thing that I recommend is to combine it with a retriever. My favorite, I like to say best by test, but really it just means my favorite, is the auto-merging retriever in Llama Index. And to talk about that very, very briefly, it just says that if we have multiple small chunks that correspond to a sequential, let's say the same page or the same document within a broader data set, I'll merge those chunks into one, do that pre-processing before I send it to the large language model to do my RAG. And then last but not least, I want to dive very, very briefly into vector databases beyond large language models, right? Where are we going with vector databases in the next 2 to 3 years? And there are so many applications out there. If we talk about any type of similarity search, any type of semantic search, right? These are all great applications of vector databases, but at the same time, there are other applications that are really on the up and up and well that have been there for, quite frankly, a long, long time. Recommender systems, any type of recommendation, UGC recommendation, product recommendation. If I'm Amazon, Shopify, and I want to recommend products, embedding users and products or user profiles of products into the same space and doing a proximity nearest neighbor search is a great way to do that. Same thing for anomaly and fraud detection, right? If I want to understand, hey, maybe which transactions are fraudulent, I can search my existing database for fraudulent and non-fraudulent transactions and see which ones come to the forefront. So, vector databases will be ubiquitous in 2 to 3 years. And if you really want to get a head start, we do have a free tier, a free managed tier. You can go to zilliz.com/free to learn a little bit more about that. And we do have Milvus as well. Milvus is fully open source. You can go to GitHub, download it, play around with it, install it as you see fit. And that is the end of my presentation. I want to thank everybody here for listening to me ramble for the better part of 20 minutes. Be happy to take any questions.
Thanks a lot, Frank. I really like that. Very succinct and detailed. And let's take some questions from the audience for Frank. And if you can, just please stand. And when you're done, pass the mic to the next person or back to me.
Testing. Hello. Hiya. I was wondering, with the availability of lots of common models for doing things like named entity extraction, that kind of thing, at what point would you consider using vector search rather than, say, using a lot of models that give you structured information as an output from that model. So where would you use vector search instead of using one of the common models that gives you structure?
Yeah, great question. You would want to use vector search if you're trying to represent your input data in a particular way. So if you have, let's say, I'm going to use ImageNet as an example. If you train a model on ImageNet and it gives you, 1,000, it has 1,000 outputs, which is a probabilistic distribution over what the input might be, what your image might be, right? The downside to that is you lose a lot of potential semantic information if all you're doing is doing softmax over 1,000 classes. And it's the same thing you were talking about any type of NLP application, name that need recognition, so on and so forth. If you want to represent your input data, if you want to turn that into something that a machine can understand through approximate nearest neighbor search, that is when you would want to leverage a vector database. If you have lots of data, that's also another instance when you'd want to leverage it. And also if you want some type of explainability as well. And the reason I say explainability is because as you do ANN search and you search for the most relevant bits and pieces of data, you can get a better understanding for why the ML model views a particular input the way that it does, just simply by understanding its nearest neighbors in this high dimensional space. Hope that answers your question.
I have a question about vectorizing large documents. If you have, say, books or something, which kind of model would you choose to create embeddings that comprise pretty large text?
Great question. For large text, even if you have a very, very long context length model, let's say 8K, 16K, and you can generate embeddings using all of those, because you're fitting so many tokens into a fixed length embedding, you actually end up getting worse performance. I actually always recommend doing some sort of chunking, because that way you never sort of miss a lot of the information in the middle, and you don't try to distill, let's say, a whole book of information into a 1024 or 1536 dimensional embedding, right? Always, let's say, I think about a paragraph is a good place to start. Chunk a paragraph and then use some of those retriever techniques I was talking about a little bit earlier. I'm going to go back to the slide here, such as the auto-merging retriever, to give you better results, to help you agglomerate more of those results together after your vector database.
Chris, there's a lot of talk about re-ranking the results, prompting, all of that. How would that fit into your architecture?
Yeah, great question. I'm actually not a prompting expert. I'm not a prompt engineering expert. I would say that is one thing that I actually left out of this talk. The reason I did is because for each and every large language model, the prompts that you want to use are going to be a little bit different. If you're using, even between GPT 3.5 and GPT 4, which is the same quote unquote class or family of models, the prompts that you want to use are going to be a little bit different. And for Llama to Llama 2, the prompts are going to be a little bit different. I always recommend doing a bit of experimentation. You can use some of the canned prompts on LangChain to see which ones work best. But at the same time, it's also important, I think, to understand what the LLM is good at. Different LLMs are good at different things. And to be a part of the broader, particular LLM community as well. That can give you great insight into what the LLM is good for when it comes to prompting.
All right. Two quick questions. One is the embedding model independent of the LLM? Okay. And the other question is, when you save the vector in the vector database, can we also save metadata or?
Great question. So yes, the embedding model is independent of the LLM. Now, people, when folks use the OpenAI embedding endpoint, they usually call it GPT embeddings. This is not right. So GPT stands for Generative Pre-trained Transformer, and it is an autoregressive model. It's trained unidirectionally. It's trained causally. When you generate embeddings, you want a bidirectional model. You want something that's trained with MLM, masked language modeling. So these are actually two completely independent things. The second question was, can we save metadata in addition to each vector? And the answer is yes. So in Milvus, along with a lot of other vector databases, you can save, we call it scalar fields. You can save metadata of a variety of different types. It can be strings, floats, so on and so forth. And those can correspond to, let's say, if I'm, let's say, a product, and I could have metadata attached to that product that tells me who the seller is. It could also say, okay, where specifically is the seller in terms of geolocation. And that is another aspect of vector databases. It's very powerful as well. Thank you for that question, by the way.
Any more questions for Frank from the audience? Anyone else? Let's take one more. If you guys can help me pass this.
Hi, name's Devinder. Have you seen some success with getting, I guess, closer to deterministic answers using RAG as a technique?
Yeah, that's a great question. RAG will never give you perfectly, so unless your LLM is 100% deterministic, unless you have, unless you set your temperature to be, max temperature, you will not get deterministic results from RAG as well. But with that being said, with the proper prompting strategies, with the right embedding model, with a solid vector database as well that gives you good recall, you can actually minimize both hallucinations as well as any LLM that really goes totally off the rails. It's never going to be perfect, but it does get you one step closer to production, to use RAG, to use a lot of these strategies that I was talking about in here.
Okay, let's give Frank a round of applause. Outstanding. Thanks so much. Okay, if you had a good time tonight and you want to show your support, please follow us on Twitter and LinkedIn. We are doing the live stream to both those platforms and pushing out content as well. You can see the replay of these talks there. So we'd appreciate it. And yeah, give us a follow. Go to meetup.com. You probably registered for this event there. If you want to see our next events, here are the dates. If you like the AI for developers, the next one's on November 29th. All 3 speakers are posted. So just have a look if you're into it. We'd love to see you again. In 2 weeks, we have AI for marketers, all the speakers posted, and AI for designers on November 15th. So just take a look at that. And now by request, we have this is by request from you guys. We have an open mic for like 5 minutes. It'll kick off networking. We'll start networking after this. It's a good way to introduce yourself to the audience. These are relevant things you can talk about. Let's keep pitches to 60 seconds max and have some continuity with our presentations. But first announcement is from Patrick. So let's have him take the stage, and LinkedIn can see you as well, Patrick.
Hello, LinkedIn. All right, so I'm going to start this off. So I mentioned this before, but the AI Developer Conference, I'm the conference chair for both AI.dev and for Cassandra Summit. It's in December. It's in San Jose. Now, why should you go? Because there is no other AI event that's going to have Apple, Uber, Netflix, Bloomberg, and DataStax, right? I mean, no, but that's the talks that are already lining up right now are pretty phenomenal. You don't want to miss this, and it's a pretty cheap event. And if you need discount, hit me up on LinkedIn. I have discount codes. But it's going to be the last event you're going to go to by the end of the year, and then you start all over again in January, right? So I hope to see you there. It's local. It's a Caltrain away, so see you there.
Local, Caltrain away. We've all taken Caltrain. It's a pleasure. We know this. Okay, yeah, that's December 12th and 13th. So check that out, guys. What else? Next announcement. Let's keep it going. And
hi, LinkedIn. Hi, everybody. My name is Sean. I run a technical recruiting firm. I specialize in working with AI, ML startups. So some of the roles I'm recruiting for right now are senior level roles in software engineering, machine learning, data science, etc. So if you are a senior level candidate and you are interested in working at a startup, making the move from big tech to the startup world, come talk to me. We can have a productive conversation. Also, since I started my firm kind of in the middle of the recession, I've had a lot of job seekers reach out to me kind of in disparate situations. Some people have visa situations, etc. So if you're a job seeker and you need help, I have built a variety of solutions that could be, helpful for you, and I'm continuing to innovate in that space. So please come have a conversation with me. I'll be walking around and socializing with all of you. Thank you, guys.
Thanks very much. Anyone else for an open mic announcement? Just a chance to introduce yourself. It could be as important as a job opening or just saying your name up here and to get us started. Anyone else? Okay. Oh yeah, look at this. See this? Look at this.
Hi guys, my name is Nick. I'm from a company called Allcode. We have been in Bay Area for about last 8 years. We are an AWS advanced consulting partner and always looking for opportunities. We also are looking for AI ML developers. I'll put my cards over there, feel free to reach me on LinkedIn or send me an email. Thank you.
Thanks very much.
Hey everyone, I'm building a social commerce app. We already launched and looking for an AI partner who can join our team. It's mostly based on the streaming platform as well as shopping. So please meet me in the socializing if interested to learn more. And I'm just looking forward to socialize and meet people in the similar space. Thank you.
Okay. Anyone else with an announcement? Okay, come on up.
I'm Justin from Superpowered AI. So I'm one of the co-founders, and we actually have kind of a free research preview trial going on right now. So it's a RAG API. It is a little bit different from LangChain in that it's just a bunch of REST API endpoints that you can use, abstract away the vector database component. There's actually, we have a bit of a different take on the vector database. It's not an HNSW in-memory vector database. It's actually disk-based, and yeah, just it's free right now, so you can try it out, superpowered.ai, if you're curious to make RAG applications pretty easily. So,
Thanks very much. Really appreciate that. And my colleague Alexa, raise your hand. She has more info on the conference. If you guys are curious, you can ask me as well. I think that'll probably conclude our open mic announcements. But yep, there it is. There's a QR code. And yeah, thank you so much for being here. I hope you guys like the content. If you have any feedback, let me know. And let's start networking. We have some pizza. Let's get to know each other. And thank you very much for being here. We appreciate it. And thank you, LinkedIn.
Thanks for organizing. Yeah, it's been good. It's informative. I learned quite a bit today, and I have some more things to follow up on. I took a few notes. Oh, good. Yeah.